students, welcome to 60 out of 60 KCET Chemistry 2025 series. So as you all know, we have launched the first test of our KPL, that is KCET Premier League, and I hope that all of you would have downloaded the question paper and solved the questions honestly. So now it's time to check the solutions of those questions and see what is our level of preparation. Now those students who haven't downloaded the question paper and haven't attempted the test, for them no worries, you can still attempt the test, okay? So please join our WhatsApp channel. The link of the WhatsApp channel is there in the description section. So go there, join the WhatsApp channel, download the question paper, solve them, and then come back to see the solutions, okay? And now those students who have attempted the test, honestly, for them what you have to do now, you need to see the solutions, you need to give yourself marks, that if you are getting a correct answer, give +1, and if you are getting wrong answer or you haven't attempted the question, then you have to assign 0 marks, okay? Then after this whole video is done, after you have checked all your solutions, you need to tell me the total marks that you have scored in the comment section, okay? So yes, now let's get started. I know you all are very curious to know the solutions. So yes, now let's get started without any further delay, okay? So yes, I'll tell you the test was from the chapter Solutions and Electrochemistry, which we have covered this week, right? So I have covered these two concepts. So both these chapters you should have revised, and I hope that you would have done well in the test, okay? Fine. Now let's go to the first question here, that is okay. Molecularity you need to find. Molarity of 20% solution of urea. Okay, sorry, molarity you need to find 20%. So very simple question this one. What is 20% means? W is 20 gram. Okay. Next, the 20% W by V means volume of the solution is 100 ml. Okay, volume of the solution is now 100 ml, molar mass is 60. You need to calculate molarity. So nothing, very easy question. Molarity is formula is what? Given mass by molar mass into 1000 by volume of the solution in ml. Okay, let us substitute the values. Given mass is 20, molar mass is 60 into 1000, right, by volume of the solution is 100. Now if you solve this, you will be getting 3.33 something. So the most appropriate answer for this question will be option number D. Okay, now coming to the next question here. So if you have got this answer correct, assign +1 for you. Okay, now coming to the next question. In a solution of 7.8 gram of benzene and 92 gram of toluene, the mole fraction of the benzene is. Okay, so this question is again from your concentration terms, right? Mole fraction. Okay, so we have been given with the mass of benzene. So mass of benzene is 7.8 gram. Molar mass of benzene is 78 gram, right? Now mass of toluene is 92 gram, and if you calculate, the molar mass of toluene will also be coming as 92 gram. Okay, now let us calculate the number of moles here. Number of moles is given mass by molar mass, so 7.8 by 78, that is 0.1, and number of moles of toluene is 92 by 92, that is 1. Right, now we need to calculate the mole fraction of benzene. So mole fraction of benzene will be equal to number of moles of benzene by number of moles of benzene plus number of moles of toluene. Now number of moles of benzene is 0.1, okay, and number of moles of this 0.1 plus 1, okay. So we'll get 0.1 divided by 1.1. So that is mole fraction of benzene is 1 by 11. Okay, so now if I solve this, we will be getting around 0.09. The correct answer for this question will be option number C. Okay, so now going to the next question. 10.6 W by V Na2CO3 solution and 6.3 W by V H2C2O4.2 H2O solution have the same. Okay, so if they have the same molarity, if these options you see, they need to have the same number of moles. If the number of moles is same, then the molarity may be or may not be same. So first thing we need to check is the number of moles. So let us calculate here for Na2CO3, right? So the given mass is 10.6 gram, we can say, and if you see the molar mass of this one is also 106 gram. Okay, you can calculate, you can check, molar mass is 106 gram. Now coming to H2C2O4, so for H2C2O4 dot 2H2O, okay, the given mass is how much? Given mass is your 6.3%, okay, and molar mass if I want to calculate, so let us do this. So 2 for hydrogen, carbon is 24, okay, 16 4s are 64, then 36, right? So I will add this, so I will get 6 plus 4, 10, 14, 15, 16, 1, 6, 7, 8, 9, 10, 11, 12, 126. So 6.3 by 126, so that is your 0.2, right? Sorry, 6 ones are, I'll get 1 by 2, or I'll say sorry 1 by 20, so that is 0.5 into 10 to the power of minus 1, so I can 0.05, right, 0.05. So now you see this moles is how much? If I calculate number of moles here, 10.6 by 106, so that is 0.1. So because the number of moles are completely different, these three terms cannot be equal. The correct answer for this question will be option number D, that is none of this. Okay, very simple question. So this question is also from your concentration terms. Now coming to the next question here, the value of Henry's constant. So this question has come from your solubility, right? Solubility concept. Okay, so if you know Henry's constant, we can directly remember this formula, P is equal to Kh into mole fraction, and if you see Kh will be equal to P into mole fraction. So I can say Kh is inversely proportional to mole fraction, which is the meaning, which is solubility, right? Kh is inversely proportional to solubility. Now what will happen? If the mole fraction increases or solubility increases, Kh will decrease. If Kh increases, solubility will decrease. So now if you see Kh will be greater for gases with higher solubility? Definitely no. If higher solubility will be there, Kh will be low. Kh will be greater for gases with lower solubility. Yes, that is correct, because if gas solubility is low, then Kh value will be high because of inverse relation. The correct answer for this question will be option number B. I hope everybody would have done this correct. If yes, please assign your marks. Now coming to next question. Question number 5. The solubility of O2 at a certain pressure P and temperature is given to us. If Kh of O2 is 35 kilobar, the value of pressure P is. So again, this is Henry's law constant, Henry's law formula. P is equal to Kh into mole fraction. Here a trick is there, that is this one, grams per liter. What does it mean? That 0.08 grams of oxygen in 1 liter of water, right? So what is there? I can say that 1 liter of water, its mass will be 1000 gram, okay, because 1000 ml and 1 ml density is 1 gram per ml. So I can say that 1 liter of water is 1000 gram. Now coming to this one, if I calculate the number of moles of O2, that is equal to given mass by molar mass, okay, and number of moles of, so I can write it like this, that 8 by 32 into 1 by 100, so 8 ones are 4s are, so 1 by 4 is 0.25 into 10 to the power of minus 2, okay, and number of moles of water, that is given mass 1000 by molar mass 18, that is 55.55. Okay, so now we have got these values. Let us substitute. We need to calculate the pressure. P is there. Kh is 35 kilobar, so we need to convert it into bar. 35 into 10 to the power of 3. Mole fraction of water is your number of moles of oxygen, that is 0.25 into 10 to the power of minus 2 divided by 55.5. Okay, so now if I solve this, we will be getting around 1.58. The correct answer for this question will be option number B. This question was very easy, but little tricky lies in this part. Okay, how to get the mole fraction from the concentration given in grams per liter. Okay, I hope you would have understood this right now. Okay. Now coming to the next question, at 40 degrees Celsius, the vapor pressure of pure liquid benzene. So vapor pressure of benzene and vapor pressure of toluene. Okay, benzene is 80 and toluene is 60. At the same temperature, the vapor pressure of equimolar solution. Now equimolar solution means I can say that number of moles of benzene is X, the number of moles of toluene is also X. Now if this is there, then can we tell the mole fraction? What will be the mole fraction of benzene? X by 2X, or that is 0.5. Similarly, mole fraction of toluene will also be 0.5. Okay. Now if I want to calculate the total pressure, that will be pressure of benzene 80 into 1 by 2, that is mole fraction of this one, plus 60 into 1 by 2, right? This is Raoult's law formula. This question is from your Raoult's law, right? right? So if I solve this, I'll get 40 plus 30, 70. So the correct answer for this question will be option number C. Okay, very easy question. Now coming to next question here. If an azeotropic solution has a higher boiling point than both of the mixed liquids in case of, see, if that is higher boiling point, if it is higher boiling point, then it is which type of azeotrope? Maximum boiling azeotrope. And maximum boiling azeotrope is shown by the solutions having negative deviations, right? The correct answer for this question will be option number B, negative deviation from Raoult's law. Again, very easy question. So this question has come from your ideal and non-ideal solutions topic, right? Now coming to next one. Which of the following liquid pairs will show a positive deviation from the Raoult's law? Positive deviation. So that means positive deviation means the attraction should become weak, right? For if you see now benzene and methanol, methanol have very strong hydrogen bonding, but once you put benzene in that, this hydrogen bonding is disrupted. So the interactions become weaker. So the correct answer for this question will be option number D. Okay, very simple. Next, move to the next question. Again, this question is also from your ideal and non-ideal solutions. Okay, now coming to the next one. The mixture that forms maximum boiling azeotrope is. So again, if I want to form maximum boiling azeotrope, right, then it should show negative deviation, right, and negative deviation is shown by water and nitric acid. Okay, this is also a direct example. So the correct answer for this question is option number B. This example is directly there from the NCERT, right? So please remember that examples are very important for this particular section. Okay, coming to the next question here. Which of the following binary liquid solutions obey Raoult's law? So if you know heptane, hexane and benzene, toluene examples are given. So the correct answer for this question is option number A. Direct answer. Direct example based question. Again, this is also from ideal and non-ideal solutions topic, right? Okay. Now we have completed the first 10 questions. Please comment down your scores out of 10, how much you have got. Now let us move to the next 10 questions, that is question number 11. An aqueous solution of Ki is 1 molar in Ki, which change will cause the vapor pressure of the solution to increase. Now see, very logical thing. When we add a solute, what will happen? The vapor pressure decreases. If we add solute, vapor pressure keeps on decreasing. So it is asking you to increase the vapor pressure. So if I add NaCl, further vapor pressure will decrease, Na2SO4, it will decrease, Ki will decrease. But if I add solvent, then vapor pressure will increase because it is a volatile substance, right? The correct answer for this question is option number D. Now coming to the next question, 12. A 0.5 molar aqueous solutions of KCl. So we have KCl, MgCl2, okay, and FeCl3, okay. The boiling point, so here I values are 2, 3 and 4. Okay, now what will happen? If you remember freezing point, delta TF is equal to I into Kf into M, right? Now what happens here? I value, if it is more, then delta TF will also be more, depression will be more. Now what will happen here? Depression will be less, here depression will be more, here depression will be further more. So where the freezing point will be least, here the freezing point has decreased maximum. Like for example, if you see, suppose it was 20 degrees Celsius, let us assume. Okay, here decrease will be less, it will come to 16. Here decrease will be in between, here maybe it is I'll tell 14, right? But here maximum decrease, so maybe it is 12 here. So where the freezing point is maximum now? Here, right? So this was your T1, this is T2 and T3. So T1 will be greater than T2, greater than T3. Correct answer will be option number A. Okay, this is very tricky. When freezing point depression is more, that means the freezing point has gone very down. So it will be the least value. Okay. Now coming to question number 13 here. 1 gram of non-electrolyte, non-volatile solute of molar mass 250 gram per mole was dissolved in 51.2 gram of benzene. Okay. If the freezing point depression constant is 5.12, the freezing point of the benzene is lowered by. So we need to calculate the delta TF value. Because it is non-electrolyte, so I value will be 1 Kf into M. Okay, let us substitute the values. Kf is what? 5.12, right? Molality, given mass by molar mass, what is? So I'll write given mass is 1 gram, molar mass is 250, right, into 1000 by mass of the solvent is 51.2. Okay, so now if I solve this, I'll get this one 4. Okay, Now here if I want to calculate, so it is, I can write it like this, 512 by 100 into 512 by 10 into 4, right? For decimals you can just do. So I'll get 2 2s are 4, 2 5s are 10, so 2 by 5, that is 0.4. The correct answer for this question will be option number D. So this question is from your colligative properties, most important topic from the solutions chapter. Okay. Now let us move to the next question. A 5% solution of cane sugar is isotonic with 1% solution of an unknown solute. The molar mass of the unknown solute is. Yes, this question is from your osmotic pressure. When you mean isotonic, that means the two solutions have equal isotonic osmotic pressure. So I can say that pi 1 is equal to pi 2. Okay. So I can say that pi 1 can be written as C1 RT is equal to C2 into RT. Okay. Now RT we can cancel. C1 is what? Concentration, right? So I can write W1 by M1, okay? W1 by M1 into 1000 by volume of the solution is equal to W2 by M2 into 1000 by volume of the solution. Now since it is 5%, that means mass of the solution is 100 gram. Here also mass of the solution is 100 gram. Volume will be same, so we can cancel these terms also. So what is the equation that we are left with now? W1 by M1 is equal to W2 by M2. Okay. Now let us substitute the values here. What is W1 value? 5 by 342 into W2, we need to calculate 1 gram. W2 is 1 divided by M2, right? So if I calculate M2, I'll get 68.4. The correct answer for this question is option number D. This is a little tricky question. Here you need to equate the two osmotic pressures. Okay, I hope you are getting these answers. Let us go to the next question now. Vapor pressure of benzene and toluene at certain temperature are 400 and 150. So I can write vapor pressure of benzene is 400 and vapor pressure of toluene is 150. Okay, and 3 moles of benzene is taken. So benzene is 3 moles and this one is 2 moles. Right. Now what is the mole fraction of benzene? That is 3 by 5, 3 by 3 plus 2. Mole fraction of toluene, that is 2 by 5. Let us calculate the total pressure here. Okay, you have to use Raoult's law. So this question I can say is from Raoult's law. Okay, so now PT, total pressure is what? XB into P naught B, that is 3 by 5 into 400, right? Plus here 2 by 5 into 150. So now if I solve this, I'll get 240 plus 60, that is 300, right? The total pressure is 300. Now if I want to calculate the mole fraction of benzene, okay, P of benzene by P total. So what is pressure of benzene here? If you see, it is 240 by the total pressure is 300, right? So if I solve this, I'll get 3 8s are 24, 3 10s are, so 0.8. Right, and if I now to calculate Y of toluene, okay, so that is 1 minus 0.8, so that is 0.2. The correct answer for this question will be option number C, 0.8 and 0.2. Now coming to the next question, question number 16. So now we have completed solutions questions. Now we are going to move towards electrochemistry question. The number of Faradays needed to reduce 4 gram equivalent of copper 2 plus is equal to. So remember here, 1 Faraday reduces 1 gram equivalent. Okay, so if I want to reduce 4 gram equivalent, okay, 4 gram equivalent, I will require 4 Faraday, right? So the correct answer for this question will be option number D. Very simple and easy question. Next question. During the electrolysis of a concentrated aqueous solution of NaCl, the gas produced in cathode is. This I have discussed very in detail in my lecture. You must have watched it. So in aqueous solution, hydrogen is there, so that will get reduced. So the gas produced will be option D, that is H2. Now coming to question number 18. If the same amount of electricity is passed, so that is Faraday's second law, right? Same amount of electricity is passed through AgNO3 and CuSO4 and the number of Ag and Cu atoms deposited are X and Y respectively. Then, okay. Now see, Cu2 plus is there. How will Cu get deposited? By getting 2 electrons. Now how will silver getting deposited? By gaining 1 electron. Right? Cu2 plus 2 electron is copper, Ag plus 1 electron is silver. Now what I can say that 1 Faraday Okay, this 1 mole of electron is 1 Faraday. 1 Faraday deposits 1 mole of Ag. Okay, and I can say 2 Faraday deposits 2 Faraday deposits 1 mole of copper, right? Now if you see 1 second. Okay, now if you see 1 Faraday deposits 1 mole and 2 Faraday deposits 1 mole of copper. Now suppose it is telling that same amount of current is passed. Let us assume that 4 moles of current is passed, just like this, randomly. Okay, randomly, I am just considering it randomly. If 4 Faraday is given, 1 mole deposits 1, so 4 Faraday will deposit 4 moles of silver, right? And for silver we have used the term X, so I will tell this is X. Okay, now if I pass 4 Faraday, how many moles of copper will be deposited? 2 moles of copper will deposit, right? This is 2 moles, this is like half of that one, so 4 moles will deposit 2 moles of copper, which is Y. So now what I can say that this X is 2 times of Y, right? X4 is 2 times of 2, right? So that is what we will get option D as the correct answer, that is X is equal to 2Y. This question I will tell is little tricky, not very easy, but yes, if you have understood the concept, it is a doable question. Now coming to question number 19. 2 Faraday of electricity is passed through a solution of copper sulfate, the number of gram equivalents of copper deposited. So this is the question from Faraday's first law, right? So just now I told you that 1 Faraday deposits 1 gram equivalent, right? So 2.5 Faraday will deposit 2.5 gram equivalent. Very simple. The correct answer for this question will be option number C. You can do first law, use the formulas and still solve it, but this will take you just 10 seconds to answer this question. Now coming to question number 20. A current of strength 2.5 ampere. So current is given to you as 2.5 ampere was passed through a copper sulfate solution of time 6 minutes 26 seconds. So total in seconds it will be 386 seconds. The amount of copper deposited, we need to calculate mass of copper deposited. Yes, so this question is from your Faraday's first law, right? Let us use the formula. What is it? M is equal to Z into I into T. What is Z? Molar mass divided by N into 96500 into I into T. Now what is N? If you see copper, how will copper deposited? 2 plus 2 electrons give you copper. So N value is 2 here, right? So if I want to substitute here, 63.5 divided by 2 into 96500, current is 2.5 ampere, time is 386 seconds. So if I solve this whole thing, I will be getting around 0.3175 gram. Okay, the correct answer for this question will be option number A. Okay, so this is also a direct question. I hope everybody would have done it. Now we have completed the first 20 questions. So now please comment down how much marks you have got out of 20. Okay, so now we are going towards the last 30 questions. Let's get started. A conductivity cell having cell constant of 8.76 centimeter inverse. So this question has come from your conductance, right? A very important topic, students, conductance. A conductivity cell having a cell constant is given. So let me note down, cell constant is 8.76. Okay, is placed in a 0.01 molar solution. So concentration is 0.01 molar solution of electrolyte. Offered a resistance is given, that is 10 to the power of 4 ohm. Okay, next, what is the specific conductance? If you remember, specific conductance is nothing but kappa or conductivity. Okay, so what is the specific conductance of the electrolyte? So just let us put the formula for kappa. Kappa is equal to 1 by R into L by A, right? So now what is 1 by R? 1 by 10 to the power of 4. L by A, what is the value of L by A? 8.76. So how much I will get? 8.76 into 10 to the power of minus 4. The correct answer for this question is your option number B. See how the options are very confusing. 4 minus 4 is given, right? So you need to be very, very careful while choosing the options. Okay, so the correct answer for this question will be option number B. I hope everyone would have done this correct question. Very easy question. Only thing here, the trick is to know that specific conductance only is conductivity. Okay, conductivity and specific conductance are the same thing, used as symbol kappa. Okay, let's move towards the 22nd question. For an electrolytic solution, again this is from conductance, the question is from conductance. Okay, now for an electrolytic solution of 0.05 mole inverse, so let me write the concentration is given 0.05. Okay, the conductivity has been found to be, conductivity means again kappa is 0.011 s centimeter inverse. The molar conductivity is how much? We need to calculate the molar conductivity. So again this is also direct formula. Molar conductivity formula is what? Kappa into 1000 by C, right? So if I see now kappa into 1000, what is kappa value? 0.011. Okay, 1000 is 10 to the power of 3, and then concentration if I put, that is 0.05, right? Yes. So now if I see, this is, I can write it as 11, okay, into 5 by 100. So I can write 520s are, so 220, right? So the correct answer for this question will be option number D. Okay, again very simple direct formula based question. Let us go to the next question, question number 3. The conductivity of, again this question is also from conductance. Okay, the conductivity means kappa value is given. Kappa value, concentration is 0.01. Aqueous solution acetic acid is 19.5 into 10 to the power of -5, right, s centimeter inverse. And the limiting molar conductivity, that is lambda naught m. The limiting molar conductivity of acetic acid is 390 s centimeter square mole inverse, right? Okay. At the same temperature, the degree of dissociation. So degree of dissociation, if you are remembered, we have studied in the applications of Kohlrausch's law, that is lambda m by lambda naught m. Now you can see that lambda naught m value is given. Then how to get lambda m value? Again you can see kappa is given, concentration is given, all data are given to us. So first let us calculate lambda m, that is kappa into 1000 by C. Let me substitute. What is the value of kappa? 19.5, right? 19.5, and then we have into 10 to the power of -5. Okay, then I have 10 to the power of 3 here. Then concentration is how much? 10 to the power of -2. So if I see, it will get cancelled, I'll get 19.5. Okay, now let me substitute for here, that is 19.5 by 390. Okay, so I can get it as 195 by 3900. So 39, if I use 39 fives are and 39 hundreds are, right? So I'll get 0.05. So the correct answer for this question will be option number B. Again very simple question, but you need to know little 2-3 steps have been involved here. Okay. Coming to the next question, question number 24. The conductivity of a saturated solution of barium sulfate is 3.0, conductivity means kappa value is 3.06 into 10 to the power of -6. Ohm inverse means S, then centimeter inverse. And its equivalent conductance is, okay, here a small error is there, this is 1.53. Okay, equivalent conductance is 1.53 S centimeter square equivalent inverse. Okay, now the KSP for barium sulfate will be, okay, so if I have barium sulfate, how will it dissociate? It will dissociate to give you barium 2 plus and SO4 2 minus, right? Now what is this S? Suppose the solubility of barium is S and a sulfate is S. Then how can I write KSP? KSP is S square. Okay, so we need to calculate, so S is nothing but concentration. Okay, so we need to calculate this concentration from here. Now lambda equivalent is very much similar, the formula is very much similar to lambda m, molar conductivity, so you need not vary here. So I can cite lambda equivalent is equal to kappa into 1000 by C. So what will be C value now? Kappa into 1000 by lambda equivalents. Let us substitute the values for concentration. What is the value of kappa here? 3.06 into 10 to the power of -6. Then this is 10 to the power of 3 divided by lambda equivalent is 1.53, right? Now if I substitute, it will get 2 into 10 to the power of -3. Now if I take S square, then I'll get 2 into 10 to the power of minus 3 square, that is 4 into 10 to the power of minus 6. So this is my S, right? So KSP is S square. I just substituted it, 4 into 10 to the power of minus 6. The correct answer for this question will be option number D. Here a small error, that is 1.53. Okay. Now moving to question number 25. Which of the following statement is correct for a galvanic cell? Okay. Galvanic cell, if you remember, the first lecture we completed, reduction occurs at cathode. Yes, that is correct. That is not only for galvanic cell. In every cell, cathode means there is reduction. Oxidation occurs at anode. This is also true for all the cells, that anode is where oxidation takes place. Electrons flow from anode to cathode. Now, if you remember the Daniell cell, zinc was the anode, their electrons were produced and the electrons moved from the external circuit towards the copper electrode, right? So, I can say that the electrons move from anode to cathode. So, all the three statements are correct. So, the correct answer for this question is option number D. Okay, fine. Now, let us go to the next question. Question number 26. The standard EMF of Daniell cell is 1.1 volt. Okay, standard EMF, that is E naught value is 1.1 volt, and the maximum work it can do, that is delta G, is equal to minus NF E naught of the cell. Right? Let us substitute the values for Daniell cell. If you remember, zinc and copper, number of electrons used is 2. So I can substitute, this is 2 into 96500 into 1.1. So if you multiply this, we will be getting around 212.3. The correct answer for this question will be option number A. Okay. Now let us move to the next question, that is 27. The standard reduction potentials of the three electrodes P, Q, R are given. Okay, let us note down the standard reduction potential for P, Q and R. The standard reduction potential of P is minus 1.76. For Q it is 0.34, right? And for R it is 0.8. Now standard reduction potential, if I arrange them, reduction potential order, so it will be P, then Q and then R. Now if reduction potential is less, then oxidation potential will be highest, right? So I can write oxidation potential order is this one, right? Now why we calculated oxidation potential? Whether a metal can displace another metal or not, that depends on the oxidation potential. So if P is having the highest oxidation potential, then P can displace Q and R. Q can displace R, right? P can displace both Q and R, but Q can displace only R. R cannot displace anything, Q cannot displace P. Okay, now let us do this question. Q will displace cation P. Can Q displace P? No, right? Because oxidation potential of Q is less. So this statement is wrong. Next, both metals Q and R both will displace P? No, because their oxidation potential is less than P. So this statement is also wrong. Next, R will displace P. R cannot displace P because R oxidation potential is less than P. So this statement is also wrong. Next, P will displace R. P can displace R because P's oxidation potential is more than R. So the correct statement for this question will be option number D. So this question has come from your electrochemical series. Okay, but the concept is your oxidation and reduction potential. Let us move to the next question here. Aluminium displaces hydrogen from acids but copper does not. Okay, aluminium can displace hydrogen but copper does not. That means copper, see, aluminium can displace hydrogen, means aluminium oxidation potential is more than hydrogen. Now copper cannot displace, so oxidation potential. Okay, we are talking about oxidation potential. See here, aluminium can displace hydrogen, means aluminium oxidation potential is more than hydrogen. Now copper cannot, that means copper oxidation potential is less than hydrogen. Okay, now if I talk about the reduction potentials, the order will change. So aluminium, hydrogen and then copper, right? Now if you see, they are telling that combining copper and aluminium has an EMF of 2 volt. If the potential of copper is this much, what is the potential of aluminium? Now you see, if you see in a cell, there has to be a cathode and there has to be anode. So cathode is the one which has the more reduction potential. So if you compare aluminium and copper, copper has more reduction potential. So in this particular cell, copper will behave as a cathode, right? So if I now write the cell, E naught of the cell is equal to E naught of cathode minus E naught of anode, right? Let us substitute now. What is E naught of cathode? Copper value is 0.34 minus E naught of anode. And what is the value of E naught of cell? E naught of cell is 2 volt. Right? Now if I calculate E naught of anode, that will be equal to minus 1.66 volt. The correct answer for this question is option number D. Okay, very easy question, but you just need to know which can be the cathode and which can be the anode. Okay, so this question again I'll tell from electrochemical series. Coming to the second last question, the standard reduction potentials, again it is given. See, for copper reduction potential is given, then I have zinc reduction potential, then I have lithium reduction potential, right, then I have silver reduction potential, and then lastly hydrogen reduction potential is also given. Okay, now if you see, copper reduction potential value is 0.34, zinc is minus 0.76, lithium is minus 3.05, silver is plus 0.8, and hydrogen is 0 volt, right. Now what happens? The question is asking for strongest reduction agent, right. Okay, first let us arrange them in the reduction potential order. Whose reduction potential order we will arrange it? Which is the least one? If you see, minus 3, right. Lithium is the least, then we have, after this we have zinc, right, then we have hydrogen. Okay, so this is your least one, then I have zinc, then this one, then 0 point copper, and then silver. Okay, now see, it is asking strongest reducing agent. Reducing agent means what? It will reduce others, but itself it will undergo oxidation, right. It will undergo oxidation. So if I want to calculate the oxidation potential now, it will be reverse. Lithium will have the highest oxidation potential, right. See, if reduction potential is less, that means oxidation potential is highest. Now if lithium has the highest oxidation potential, means it can undergo oxidation faster, okay, in a better way. So if it is undergoing oxidation better, then it will also behave as a very strong reducing agent, right. If a species is undergoing oxidation, it behaves as a reducing agent. Now lithium undergoes strong oxidation, so that will behave as a strong reducing agent. The correct answer for this question will be option number D. Okay. Coming to the last question of this KPL first test, that is the electrode potential for copper 2 plus 2E is given, copper plus electron copper are these values. What is the E naught of copper 2 plus? So this question has come from your Latimer diagram. Okay, let us try to solve this question. Now Cu2 plus, how to solve? Cu plus is given Cu. Okay, now Cu2 plus to Cu plus, this value is how much? 0.15, and then Cu plus to Cu, this value is 0.5. We need to calculate for this one. Okay, so here it is N1 is equal to 1, N2 is equal to 1, N3 is equal to 2. Okay, so now if I want to calculate here, N3E3 is equal to N1E1 plus N2E2. Okay, now let us substitute the values. We need to calculate E3, right. So N3 value is how much? 2, E3, okay, N1 is 1, E1, what is this one? 0.15 plus this is 0.5. So I guess it will be 0.65 by 2, E3, that is your 0.325. The correct answer for this question will be option number C. Okay. Yes, so students, we have come to the end of this KPL solution discussion first series. So I hope everybody would have attempted the test, and please comment down your scores so that we can understand what is the level of our preparation. Okay, and yes, those students who haven't attempted the test for any reason, please do not neglect it. Attempt the test and then check the solutions, and you also put your scores in the comment section. So please remember, weekly test which is given to you is very, very important to measure your performance. I will request you not to miss this. Okay, please do it. The hard work you do now will pay off later. You will be getting the top ranks. You can get 60 out of 60 in KCET Chemistry. So yes, please work hard from now and do not neglect the test series. Okay, so see you soon in the next episode of KPL 2. Okay, thank you for watching, and if you have found this video helpful, please subscribe the channel. All the very best for your KCET 2025 examination.